Good morning, everyone. Welcome to this session, which is part of a series of presentations which deal with the problems that were set by the South African Mathematics Foundation in relation to the SAMO, or the South African Mathematics Olympiad competitions over the years. Uh, the series aims to unpack the problems which occurred from 2023 to 2025, the junior and the senior Olympiads. We would also be looking at the team competitions. I want to pay tribute to the South African Mathematics Foundation for hosting this program. And with those few words, shall we go straight to the matter at hand. Okay, let's go to the very first question. The first few questions are quite easy, so I'm going to go through them very quickly. 1,000 identical balls are dropped into a pipe of uniform width, and as shown, the question is how many balls in total are expected to exit A. So this is A here. All right, so you got 1,000 balls are inputted here. So there's an equal chance of them spreading on both sides. Let's try to divert our attention to A. So you can expect 500 balls to go in here. And again, they spread out equally. They come to this. And so you can expect 250 on this side, 250 on that side. And once again, these are split equally to get 125. So the answer is 125. Okay, how many balls in total are expected to exit? So the answer is that. Okay, so let's just get on to the next problem. I solve all the problems and I expose the answers as well very briefly so that you can go over the answers as well. My answers need not be the same, but in the larger number of cases they are. So let's get on to the second question. The diagram shows 4 straight line segments, right? 2 of which are parallel. Determine the size of the angle y in degrees. So this is the angle that you need to look at, but this y is actually equal to 3x because these are alternate angles. You can see there's your z angle. So this is y, so this has to be 3x. So we need to work out what x is, but you can see from here that all 3 angles, they add up to a straight line. The 3x, the 5x, and the 2x, this 10x altogether, they add up to 180 degrees. Okay, so x is 18 and y is 3 times 18, which is 54 degrees. Okay, so I went through that quickly. You can check the calculations. So you can see it's 54 degrees. Okay, so let's get on to the next problem, which is question 3. Ayo and Buhle share a packet of sweets in the ratio 3:5. So Ayo gets 3/8 of the sweets and Buhle gets 5/8, because 3 plus 5 is 8. So the 8 portions altogether, he gets 3 and he gets 5. Buhle gets 2 more sweets than Ayo. So Buhle, he gets so in these ratio problems, you can say that Ayo have 3x sweets. and Buhle 5x. You see, the point is the ratio is the same as a fraction. He gets, it's 3:5. All right, and a fraction says that it's the same as 6/10. It's very important. 9/15, and so on. You can multiply the numerator by any number you like. In general, you can say it's 3x/5x. So I don't know what x is, you see. So once I know what x is, then I can put the x in and it'll be the same as 3/5. That is why I said let Ayo have 3x and Buhle 5x. Okay, so Buhle has got 2x, 5x minus 2x. He's got so many more sweets, right? And that is equal to 12. So therefore x is 6. And you want to know how many sweets did the packet contain? The packet contained 8x. And because it contains 3x of Ayos and so it's 8x, and that is 48. 8 times 6. Okay, so this is a problem on proportion. And let's just see whether this is the same as the answer. Okay, so you can see the answer there is in red, and it does say 48. So let's get on to the next problem, which is question 4. Question 4 says x, and there's a symbol there. You read that as delta. It's a symbol. It's a Greek D, the capital D. So x delta y means x squared plus xy. So in other words, if I put two numbers here, I get a third number, and that third number is y squared plus xy, which is y into y plus x. If you take the y out as a common factor. So whenever you're calculating x delta y, right, it's equal to all this. You look at this number, that is y, and you multiply it by, this is a product, by the sum of these two. So it's this times the sum of these two. So here you've got the t delta 3 is equal to 21. And we just said that this is the same as 3, this is your y, times the sum of these two, that is t plus 3, is 21. Now you got a simple equation, and you can see that t is equal to 4. All right. I'm not going to do this. It's all mentally you can do it. T plus 3 is 7, so t is 4. Okay, so let's once again just check to see whether this is the answer that is given. And yes, true enough, that is the answer. So let's get on to the next problem, which is question 5. The question 5 says, so you've got 3 points. All right, so these are Cartesian points. So there are points in the XY system. So let's just draw these points immediately, or locate these points inside a graph. They're all positive, so I'm going to use only the first quadrant. So A is 7, 3. So A, its position is let's call this X, call this Y. So the X coordinate is 7, and the Y coordinate is 3. So let's just put this A. So A is here. And B is 4, 0. So the X coordinate is 4, but the Y coordinate is 0. So let's locate this thing somewhere. So B is 4, 0. And C is 1, 3. So C, the x coordinate is 1. Y coordinate is the same as this one here. Okay, so it says calculate the angle ABC in degrees. So you need to calculate ABC. So you join this angle here. You asked to calculate this angle. All right, now I want to give some life to these numbers. And these numbers represent lengths. When I constructed these points, you will see that I actually was considering lengths to draw them. Like for instance, now here C13 means, let me drop these perpendiculars down here. So C13 means that this is 1 and this is 3. Okay, here 7A73 means, I don't know why I drew this thing so close to the bottom. Anyway, that means the distance from here to here okay, that distance is 7 and the y coordinate is 3. Okay, so you've got this part here is 1. So this point here is x coordinate is 1. And so it says now that from here to here it's 4. Right? So let's call this point D and E. I'm sorry, I drew this thing very badly. I had so much of space here. Sorry. So D is the point. It's 1, 0. And B is 4, 0. So therefore, DB, BD is 3 units from here to here. That's 3 units. So this part here is 3. And likewise, this whole thing here is 3. Okay, so you have a right angle triangle whose two sides are the same. So it's an isosceles triangle. So these two angles will be 45 degrees. So this angle here, you see, we are trying to get hold of this angle. So we can see that that angle there is already 45 degrees. And now it'll be nice if I can calculate this angle. Well, let's see now. Here you've got 7. So this entire thing is 7. And from here to here, it's 4. So therefore, this remaining part, this whole thing is 7. This is 4, this must be 3. And again, you got the same y coordinate 3. So once again, you got an isosceles triangle. So therefore, this is 45. So now you got both these angles here, and the question mark now can be very easily calculated because the other two angles are 45 degrees. So you have the question mark plus 45 plus 45. They all form into a straight line. And so therefore, the angle that you're looking for is 90 degrees. So this angle here that we're looking for is actually a right angle. Okay, so let's just get on to, let's check the solution. You can see you got a much better diagram here. So you can have a look at this and you see the answer is 90 degrees. All right, so that's fine. Let's get on to the next problem. So question 6 says, there are 65 boys in grade 9 who play sport. So altogether, the sporting youngsters are 65 in number. 35 play soccer. So let's just write down 35. They play soccer. And 42 play rugby. So all these people play sport. Okay. Now, so how many grade 9 boys play soccer and rugby? All right. Now, you'll notice that altogether, you've got the soccer plus the rugby is 77. But there are only 65 boys. So why are there 77? It means that there are, some people are counted twice. So 12 are counted twice. That's all. But those who are counted twice are those who play soccer and rugby. Right? And that equals those who play. And that's the question. How many grade 9 boys play soccer and rugby? Now, there's another way of doing this if you wanted to use what we call Venn diagrams. So, oh, so I could have drawn a picture with to show to group all the boys who play soccer, and also you group all the boys who play rugby, and so maybe this is your soccer group and this is your rugby group, and altogether you got 35 here. So suppose we don't know how many are in both. So this part here is in soccer and in rugby. So we need to calculate what X is, right? So this part here is X, and this whole thing is 35. You can see 35 plays soccer. So therefore, this has to be 35 minus X here. And likewise, there are 42 who play rugby altogether, and those people on this side will be 42 minus X. So now you can see what each group, how many it has, but we don't know what X is. But we do know that altogether you got 77. So, no, there are 65 boys. So when you add up all these things, these two together get to 35 because the X's is cancelled. 35 plus 72 is 77, but there's still a minus X here. And so that total there is the total number of boys altogether who play sport. And we are told that that is 65. So what must you subtract from 65? 77 to get 65, the answer is 12. So you could have got 12 in two different ways. I like this method here because it goes to understand you understand the problem much better through that solution. Okay, so let's just check to see whether okay, so you got 12 in grid. So that means that. So once again, you see this solution, you can read it, and you hopefully you'll get a much better understanding of the problem and its solution. So let's get on to the next problem, which is question 7. What does question 7 say? Question 7 says that for a particular assessment, a student has to obtain at least 40% to pass. If the student got 15 marks but failed by 3, how many marks was the assessment of? Okay, so you got some kind of an assessment, whatever it is, some test, and he needs 40% to pass. So 40% is the pass mark. Or the pass percentage to be precise. Now the student got 15, but he failed by 3 marks. So that means he ran short of 3 marks to get the pass. So the pass mark is pass percentage. The pass mark is 18 then, because he failed by 3 marks. So he took the post by 3 marks. So this 18, so this represents 40%. So what was the marks assessed out of? So 100%. If 18 is 40%, then what is 100%? Then it means 9 is 20%. And this is 5 20s. So this is 45. So the assessment is out of 45. See? So I'm doing it like this. 18 represents 40%, 9 represents 20%. Therefore, 9 times 5 is 100%. The other way of doing it is you have to multiply. If 18 is 40%, what is 100? So it's 100 over 40, right? Times 18. If you work this thing out, you'll get 45 again. Okay, so there are 2 ways of solving that problem. Let's just check to see whether this is indeed the solution that was given. Yeah, you can see the 45 is in red. Also, it's a 1-line solution. Okay, so that's a very easy problem. Okay, let's get on to the next problem. I seem to have lost my questions. Okay, we are at question 8. Okay, yeah, you are given fractions. A over 4 is the same as 9 over A and B are positive integers. What is the value of B? Now, you can see very quickly, you can see 12 is 3 times 4, and B must be 3 times A. You have to multiply both to get the same fraction. So this is 3A, but 9 over 3A, so 9 is equal to 3A. So what is A? A must be 3. Right? 3 times A is 9, so A must be 3. And the question is, what is the value of B? So you got 9 over A, which is 3. 9 over A is 3. And B over 12 is also 3, so B is 36. Because you got 9 over 3 equals B over 12. Right. And you can say 9 over 3 is 3. So B divided by 12 is 3, so B has to be 36. Okay, so that is, we're just looking at equivalent fractions. Or you could have seen that this is just one unknown here. So I could have solved for that unknown by cross multiplying. A squared is equal to 36. Actually, we say cross multiply, but what you're really doing is multiplying on both sides by 4A, the common denominator. When you multiply this by 4A, the 4's cancel off. You get A times A. That's how you get A squared. And here, if you multiply this by 4A, the A's cancel. You get that. But we cross multiply as a quick way of doing it. So A is equal to 6. But then you want to find what B is. So you can look at these two. Now you've got 2 unknowns, but you already know what one is. Cross multiply there again, and you get 108 equals AB. AB. 9 times 12. And A is 6. The 6B is I said A is 3. That can't be. You multiply, this is 3A. This is wrong. You can't come to this conclusion. 9 over A equals 3A over 12. That doesn't mean to say 3A equals 9, because it could be 3AX equals 12X. So I made a very big error here to say that these two numerators are the same. When you go to fractions like this, never ever say the numerators are the same, unless you say that the numerator is 3x. So that gave me the wrong answer. So this is wrong. All right. Okay, so you got 6B is 108 and B is 18. It's not 36, it's 18. All right, and the error was that I said that 9 is equal to 3A, which is quite wrong. Okay. All right, so we get on to the next problem. Let's just check to see what you've got here. You can see B is equal to 18. And it was done very quickly. It's just done through the algebra. And we've got the answer, the same answer, 18. So let's go to question 9. Question 9, so 60% of the 30 pupils in a class are girls. Well, 60% of 30 is 60 over 100 times 30 over 1. 10s cancel again. 6 times 3 is 18. So the 18 are girls. So there are 30 pupils in the class, so therefore 12 are boys. Right. Now 2/3 of the class speak Sesotho. 2/3 of 30. 2/3 of 30 is 20. Speaks Sesotho. I think it's called Soto for short. So 20 of them speak Soto in this class. What is the smallest number of girls who speak Sesotho? So 20 in this class, you got the girls and the boys, the 18 here, and the 12 boys, and 20 of these people speak this language. So what is the smallest number of girls who speak Soto? So for that to happen, you need to have all boys speak Soto. So for smallest, all boys have to speak. That will minimize the number of girls. You have to minimize it, the smallest number of girls. All boys speak Soto, and there is 12 of them. So therefore, the remaining part are girls. 20 minus 12 is 8. Is the answer. So 12 boys, and altogether there are 20. So the remaining part must be the girls who speak Soto. And that's the smallest number. Okay, so that takes care of question 9. And I think at this stage, maybe I'd better close up. Okay, so let's just check to see whether... Okay, you can see the 8 is in red there. And that is the answer to the question. Okay, so